This is part one of a multi-part tutorial to show you how to create a simple game in Greenfoot. In Greenfoot, what you want to do is go to the actor class, right-click it, and choose New Subclass. We want to create an elephant for this game, so we'll name our class Elephant. And you want to also choose an image for your actor. So here we'll just choose the elephant image. Now go into that class by double-clicking or right-clicking and choosing Open Editor. And inside each class that you create in Greenfoot, you should write a description of that class. In this case, this is an elephant, which will be the hero in our game. You also want to include your name and a version number or date. So here Chan, and this being March, we'll type March 2019. If you look at the act method down below, this is the method that Greenfoot calls continually. So every moment, this is where you want to write code that gets called continually. So we're going to write move 1, which gets our elephant to move 1 in the direction it's facing. Back to the main screen, we'll create a new elephant by right-clicking, choosing a new elephant and putting it on our stage. And when we hit the run buttons, we'll go down to the buttons below. And when we hit run, our elephant is now being moved to the right by 1 space every moment. In this part of the tutorial, I'm going to show you how to create objects in code. Okay, so we're going to go to the world class, and in the world class, we haven't described what this class is for, so we'll just replace the words there with a description. The world is where our hero lives. That's good enough for now. We're also going to make sure we have an author name and also a date. Down below this is called a constructor. This is where we define the size of the world, which is 600 pixels wide by 400 pixels tall. And underneath there, we're going to now create our elephant. To create an elephant object instance, we're going to give the name of the class, elephant, capital E. Then we give a name of a reference to the elephant object, so elephant with lowercase e equals new elephant. Then we need to add it to the world, so we'll type the words add object, the name of the instance elephant, and put it where you want. So 300, 300 would put it in the middle. So now we hit the compile button and we close this editor window and go back to the main screen. And oops, our elephant is actually lower than the middle of our screen because our world is only 400 pixels high. The elephant does still move to the right, but we'll have to change its y coordinate if we want it in the middle. So going back to the world, open the editor, and we'll see that if we change this y coordinate to 200, that should position our elephant so that is in the middle of the screen. Okay, in this tutorial, we're going to add another object. So here under actor, we'll create a new subclass, and we're going to add an apple, something that our elephant can eat. And so we'll, again, create apple, capital A, apple, to name the class. Hit OK, choose an apple picture. Then we're going to go back to the world class, and inside the world class, in the constructor called myWorld, we will create the apple instance, apple equals new apple. That's very typical of how to create an instance. Then we're going to need to add the object onto the stage in our world. So we'll say add object, the name of our instance apple, then choose a position on the stage to add it to. So 300, 0 would put the apple at the top of the stage right there. Now we also need to make the apple fall. We'd like to have the apple fall down from the top of the screen. So we'll go back to the apple class, open up the editor, and in here, in the act method for the apple, we're going to get it to do something. Now, just like all the other classes, we'd like to provide a description. This class is just an apple, which is food for our elephant. I'm the author, Mr. Chan. This is still March, so we'll put that date there. Now in the act method, this is the method that the Greenfoot framework calls every moment. We'd like the apple to fall downwards. Now we can't actually use move because move will actually move the apple to the right, so we can make use of another piece of code called setLocation. SetLocation puts the object in a particular location. In this case, we want to put the apple at its current X location, but we also want to change the Y value so that it is in the Y position plus 1. So every time the act method gets called, the apple will now be moving down on the screen. If you want to learn more about different methods that are available to you, you can go right-click, choose documentation, and show that the different methods that are available for you to use that are associated with the different objects. So apples and elephants all have X and Y values. All objects can move in the direction they're facing, and all objects can have their location set using setLocation and then choosing a coordinate on the stage. In this video, we're going to get our elephant to not only constantly move to the right, but also move in response to a key press. So what we're going to do is just look in the documentation under the Greenfoot package. The Greenfoot package is a collection of classes that we can use, collection of classes and methods that we can use to make different things happen. So one of the things in the Greenfoot package is this isKeyDown method. So we're going to use that, and isKeyDown takes a key and determines whether that key has been pressed. So you can use actually the letters, or you can use numbers, or you can even use things like up, down to represent the arrow keys. Going back to our editor, we're going to open up the elephant class, and in the act method, we're going to remove the move method, and we're going to replace it with the Greenfoot isKeyDown method. And we're going to choose if the left key is pressed down, we're going to have the elephant do something. Here we're going to have the elephant move to the left, so move -1. So that's if the left key is pressed. And we also want to check if the right key is pressed. So if Greenfoot.isKeyDown right, we're going to have the elephant move to the right by just writing the code move 1. And so after this is done, we'll just compile that. Oh, there's some errors here. So actually I used single quotes instead of double quotes. So I'm going to use double quotes. This command does need a string, and so a string is contained within double quotes. There we go. We'll recompile that, close, and then run. Okay, so when we run this, you can't see the key press, but if I press right, the elephant goes to the right, and then if I press the left arrow key on my keyboard, the elephant goes to the left. Okay, so in the next part of this video, we'd like to have our elephant actually interact with the falling apple. So here you see the elephant is just kind of going underneath the apple. The apple doesn't do anything. So we're going to write some code to actually have something happen when the elephant touches the apple. Also, if you check the documentation for the actor classes, every time you create an actor, you can actually check to see if that actor is touching another class. So using the isTouching class. Also useful is the removeTouching method. And the removeTouching checks another class and removes it if our class is touching it. So in the elephant class, we'll write some code in the act method. What we want to do here is just get the elephant to check every moment whether or not it's touching any apples on the screen. So we're going to remove the apple if our elephant happens to interact or collide into the apple. So we'll just simply type in removeTouching and then the name of the class that we want to check, so apple.class. So what that will do is every time the elephant touches any apple, that apple is going to get removed. So here we go. And the elephant, there we go, touches the apple and it's gone. The apple's gone. Okay, so in this part of the tutorial, we're going to check and learn something about random numbers. So the game's a little easy with our apple appearing at the same position on the screen. So we're going to randomize the position of that apple. So in our world class, we're going to, first of all, maybe create a new method. Let's just name it createApple. And what this method, I'd like this method to do is just create an apple instance and spawn it into our world. So just make it appear, make a new apple and make it appear on our stage. And also, yeah, in a random location. Okay, so we're not going to put any code in there just yet, but we will take the apple object creation instance that was previously in the constructor and move that code into the createApple method that we just created. So what that code does again is it'll create an apple instance and add it to the world. Now we don't want it to be added at the 300 location. We want it to be added at a random x and y coordinate near the top of the screen. So we're gonna just put x and y, create two variables, x and y, and we want to create a random number for x. So the way to do that is if you go back to the documentation view and choose package in the top left corner, you'll see that there's all these packages. One of them is the Greenfoot class, as you've seen before. And inside here, there's a method called getRandomNumber. And what happens here is if you call this method, you supply a limit. And that limit represents the range of numbers from 0 to that number. And so here we want a number between 0 and the width of our screen. So we'll say greenfoot.getRandomNumber, and inside brackets we want a number representing the entire width, kind of the width of our screen, which is 600. We know from above that our screen is 600 units, 600 pixels wide. And for the y coordinate, we're going to also get a random number. And what I'm showing here is that you can actually get the method come up really quickly by hitting Control Spacebar. Okay, so 300 is the height of our world. And the last thing we need to do is call this method inside our constructor. So every time this world is created, it's going to create a new apple. So let's find, oops, the apple got created down here. Actually, that's not what I wanted. I wanted the apple to be at the top of the screen. So actually, the y value will be 0. So we'll change that to 0. And then we'll compile, need a semicolon, recompile again, and we run it. You'll see that the apple is now at a different location. It used to be in the middle, now it's appeared to the top right. In this part of the tutorial, we're going to see how we can get the elephant to eat the apple so that the apple disappears and also reappears at the top of the screen, or a new apple getting spawned at the top of the screen. So we're going to go into the elephant class, and we're going to start by creating a new method. Let's call it eat. That makes sense. It's going to eat the apple. And in the eat method, we're going to have it actually remove the apple that it touches. So we'll just actually copy the code from above in the act method. We'll just take that code, copy it, and put it inside our new eat method. Because the eat method is going to do a couple other things, like not only remove the apple, but make a new apple appear. Okay, so we'll call the eat method right there in the act method. And now inside the eat method, we're going to check if our elephant is touching an apple object, then we're going to remove the apple that it's touching, so remove touching apple.class. But we're also going to make a new apple. So recall back in the world class, we have something called create apple. So what we need to do is actually get an instance of the world that this actor lives in. So we'll actually do my world equals my world. We're casting, and get world is a method that you can use to call to get an instance of the world that this object lives in. We have my world in brackets because we need to cast the world into the correct my world class. So inside the world class, you'll recall there's a create apple method which creates a new apple. So we'll call that method by doing world.createApple. What this method does is it eats the apple and spawns a new apple. So we'll make a little comment above saying that. So it eats the apple and spawns a new apple. And so we'll type that out and then compile and see if that works. So we'll go back to our screen, we'll run it, and then hopefully the elephant will eat the apple and a new one appears, and it does. And then you'll also see that the new one appears at a different location. Okay, so in this tutorial we're going to see how we can add some text or numbers to the screen. Like we'd like to have a score to keep track of how many apples we've eaten. Every game's going to want some kind of way to incentivize the player to kind of continue on. Okay, so we want to first of all go to the top of the screen, click on import class under the edit menu, and we're going to choose label. There's different ways to add stuff onto the screen, but label is a pretty useful class that you're going to want to use. So label, when you click add it to the you're going to have a label class appear. Now in our world class, we'll open up that editor, and in here we're actually going to now be able to create a label object, since we have a class that defines what a label is. Let me just write some comments. That code there was to create the elephant. Here's the code that creates, spawns a new apple onto the screen. And then now we want to create a label object. So label score label equals new label. That will create the score label instance. That's a new label instance. And then now we need to add it to the stage. So add object. Adds whatever it is that whatever instance you created, in this case score label. We're going to add it at position 0, 0, which is the top left of the screen. Now it says here there's no suitable constructor found. If we go back to the label class, we open up that editor, we can see, you can actually see from here that it needs a string and integer value. And what do those string and integer values represent? Well, the string represents the actual words you want to display on the screen. So the first parameter needs to be a string, and the second parameter needs to be a number representing the size of the object, the size of the font of the label. So we go back to the screen, we see this tiny little 0 in the top left corner, so we got to fix a couple of things. First of all, 0, 0 is a little bit too far up and to the left, so we'll make it 2020. It comes down a little bit. Okay, that's a little bit better, but maybe if we make that a bigger font, we're going to need to change it even more. So let's make the font bigger. Instead of 20, we'll make it maybe 80. Now when we run this, okay, it's a little bit squished up, so we'll just, you kind of keep playing with this until it fits the way you want it. So we'll make it maybe 50-50, and that looks okay for now. So now we have something that represents the score. Now when we eat an apple, nothing's going to happen yet because we haven't actually written code for that to happen. Okay, so what we want to do next is actually have a score change when we eat an apple. So inside the world class, we're going to maybe create a new method that will help us increase the score. We'll just call this method increase score, makes sense. So public void increase score. And what this method is going to do is just increase our score. Now we need an instance variable to keep track of our score in our game. So we'll just go public int score, and we'll set that equal to 0. So a score of 0 to begin with. But here's the variable that will change each time. Every time we call increase score, we'd like the score to go up by 1, score plus plus. We'd also like to show that change in our score by referencing this label. Now we're not going to be able to access this label because we've declared it inside the myWorld constructor, so we're actually going to rewrite this code so that the label object for the score is created at the top of the screen. We're going to now be able to access score label, and we're going to make the text show the actual score. Now if you hit control space, that's a little trick I talked about last time, and it'll show you the different methods you can use. Here we just want to set the value of the score label to the score, and so now the one other thing we need to do is inside the elephant class, whenever our elephant eats or touches an apple, we're going to need to now update the score. So we'll go world dot increase score. We do control space again. We see that the increase score method is available to us. So increase score should increase the score and change the label. So now when we run it and move our elephant to the apple, perfect. So our score goes up by 1. Okay, so in this part of the video, I'd like to finish it up by making the game stop when the apple reaches the bottom of the screen. So we're going to go into the world editor, and inside here we're going to add a new method. Let's call it something like game over. So here, this method is going to be called when the game ends. So we'll end the game and draw a giant game over label onto the screen. The method will be public void. Game over is an appropriate name, I think, for ending the game. So public void game over, and inside this code we will create a new label object. So label game over label equals new label, and this is a label that will show the words game over, and we need to choose a font size. Let's just try 100, and then we need to also add the object onto the stage. So that's the add object method. We need to supply the instance that we created, which is the game over label instance, and then we also need to choose a coordinate on the stage for where we would like to add this object. Let's add it to the middle of the screen so that we could choose 300, 200 because we know the size of our world is 600, 400, so half of each. 300, 200 is in the middle. So when we run this, we should have the game over screen appear eventually. Now we still have to do a couple other things. First of all, we need to create a method inside the Apple class that removes and draws the game over object. So we'll create this method. We'll create the code inside the act method of the Apple class. And in here we'll get an instance of the world that the apple lives in. So once again, that's using the get world method returns a world object that the apple lives in, and we're going to check if the apple reaches the bottom of the screen. So get y, that's the coordinates of the y coordinates of the apple. If it's less than the height of the world, we're going to I guess just call the world's game over method that we just created. So world.game over, and that should create the game over words onto the screen. The last thing would be, after we've created the game over label onto the world, we'd have to remove this object, the apple object, from the world. So we'll say world.remove object this. Okay, so see, whoops, looks like we did something wrong here. So we're going to go back to the apple class, and there it is. So instead of being less than the height of the world, if it gets to larger than the height of the world, we're going to go game over. So we'll run the code, move the elephant out of the way, apple gets to the bottom, and it's stuck. Now there's an issue here because it doesn't actually get greater to a position where it's greater than the height of the world, because the world is created so that objects are bounded to the world. If you add this parameter at the end, false, that'll make it so that objects are not bounded. If you want to check the documentation, you can do that. You can go right-click on the world class and scroll down to the constructor for every world. You can add this Boolean parameter, bounded. If you write false, it's not bounded in the world. If it's true, that means objects are bounded in the world. We don't want it bounded, so we'll write false. Now when we run the game, the apple should fall right through to the bottom, and when it reaches past the bottom, the game over should trigger.